Hello everyone, I am Chandu Mohan from Tech University, Department of Computer Science Engineering. I am doing internship in HCL. My major project title was image generation using quantum computing based generative adversarial networks. My major project was supervised by Dr. J. Arun Panian sir, and we are three members in a team. Myself, Madam Chandu Mohan, and other two was Kulban Harkrishna and Yedugut Govardhan. These are the industry details of HCL. And our agenda is will start from abstract and ends with references. Abstract, in this project, we propose a quantum neural networks using the projected quantum kernel future for an image classification task. The quantum computing neural network consists of four dense layers. The first layer collects the quantum data as an input, and the fourth layer produces the classification output of which user wants. Also, we developed a quantum generative adversarial networks using the batching technique for enhancing the number of samples in the image dataset. The proposed QNN and quantum generative adversarial networks were constructed using quantum filters. Our main aim of the project to develop quantum data using project quantum kernel features from the image dataset and to design a novel hybrid image generation technique using quantum circuits and generative adversarial networks, and to analyze the performance of hybrid QGAN and classical QGAN, classical GAN, which is already exists on networks on image generation using patchet inception distance variables. Our main scope of the project is to developing a novel hybrid image generation technique using quantum circuits and generative adversarial networks for image generation and quantum computing, and to identify the importance of quantum filters, quantum filter numbers and neurons on image generation module design. Quantum computing is a recent computing technique to solve complex problems in a short time. Quantum computing techniques were inspired by quantum physics. Qubits are used to perform quantum computing tasks. It is also known as a basic quantum unit of quantum information. Superposition and entanglement are the most important properties of qubits. Quantum applications are commonly developed on quantum circuits. It contains multiple qubits and states. Artificial intelligence and cybersecurity are the most important application areas of quantum computing. Quantum computing techniques are overcoming the high computational requirement challenge of artificial intelligence application developments. This is the literature review. This is the paper which published by the authors R. Parthasarthi and R.T. Bhaumik. In this paper, the authors proposed a quantum optical convolutional neural network for image recognition using an optical neural network. They identified that optical neural networks performed better than a traditional approach to report a novel computing based deep learning model. The quantum optical QCNN to elevate the computational bottleneck in future computer vision applications. Using the popular MNIST dataset, we have benchmarked this new architecture against a traditional CNN based on the seminal LeNet model. And other paper, the others was SLU, Yuan and DL Deng. In this paper, the authors developed an adversarial network and classification model using quantum states. So they used the MNIST handwritten data for training the quantum adversarial network and classification networks. The data was converted the quantum data for efficient training of models. In between, machine learning and quantum physics may lead to unprecedented perspective of both fields. So that were extremely challenging or even inaccessible to automated learning have been solved successfully. So these are the design and methodologies. In module 1, there will be data collection and we will filter the collected data. And in module 2, we will design the QNN and it We will tune the QNN well, and we will train the QNN in module 3. In module 1, data collection and filtration, the MNIST data handwritten digit data set was downloaded from the TensorFlow data repository, and we will filter the data which we have collected. In step 2, we will augment the data and using QGAD. The filtered data set contains only 13,779 images in both classes. The number of samples is inefficient to train the classification model inefficiently. So we will reduction using PCA. We will demonstrate the reduction using PCA. The image on augmented dataset have 88 pixels. The proposed classification was developed using only 4 qubits. So we will dimension the dataset should be reduced for suitability to QNN model. So we will reduce the pixel size from 18 to 8. And we will design the QNN and fine tune that. The proposed QNN model was designed using TensorFlow quantum library. The proposed QNN model consists of 4 dense layers. After that, we will train the QNN in step 5. The QNN model was trained on pre-processed dataset till 1000 training echoes. The anti-training and testing process was performed using a graphic process unit enabled workstation since we didn't have quantum computers. This is the architecture diagram. This is the data flow diagram. In first step, we will collect the data and filter the data. In second step, we will augment the data using QGAN, and we will reduction the using we will reduction dimensionality using PCA. After that, we will design QNN and fine tuning it. After that, we will train the QNN. This is the diagram, and this is the implementation of our project. And the conclusion was quantum computing is a modern computing technique. It overcomes the limitations of traditional computing, which were existed already with performance and accuracy. This project proposed a novel QNN model for MNIST handwritten classification tasks. The handwritten dataset were pre-processed using PCA dimensionality resolution technique. The digit images were rescaled to 88 pixels for speeding up the training process. And the proposed QNN model was trained on 12,000 handwritten data images. And these are the references we have referred from IT developers. And thank you. And our project implementation, this is our project implementation. First, we will import the Pennyland, and after that, we will generate, we will give input from drive, drive, from this here quantum GANs. From this, we will input this image. We will reduce the quality of this image to perform speed. After that, we will implement the discriminator, and we will implement the generator, and we will train the QNN, and we will iterate the output. Once I will analyze connected. Yeah, it's connected. I will run. The penny line has been successfully installed. Now we are connecting to Google Drive now. Now we have connected. Now we have connected and I implemented the discriminant. So now we are iterating the images to reduce the performance of discriminator and improve the generator performance. It will take time because of we give it a quantum computer. Will iterate up to the performance improvements of generator is greater than discriminator. In this iteration, each iteration, the discriminator performance is reducing and the generator performance is increasing gradually. Yeah, we have generator and the output is the output. Yeah, thank you all.